Okay, let's go through the kinematics questions. And I'm just going to go through all the Maths Genie ones. And let's kind of begin with question one, which I actually think when I look at the Maths Genie questions, I think the first two are probably a little bit weirder in just the way they're written, but I would do it anyway, just so you kind of get the feel. What you're going to notice is I'm using AVR every single time. Every time I start, I'm going to go do that TVR for at t equals 0, and then I'll have a look at it. I'll build my AVR first. So okay, let's have a look at this. Okay, so P moves with constant acceleration at time t equals 0. It's giving me some information. P is moving in the direction 4 plus 3 with speed 6, like I said, blah blah blah. Find the acceleration of A. So this is one of those uglyish ones because I actually don't know what A is. So I'm going to start off by calling it X and Y, and my whole aim is to find X and Y. But let's see what we do know. So I'm just going to start with t equals 0, and you know how we do that diagram. It doesn't really matter if you do that, or you could just do like, okay, t equals 0. What do I know? All right, now this is why I don't like to start off with it, because we actually start off with quite a weird one. So it's got speed 15 meters per second. Okay, but it's moving in this direction, which is kind of like a weird way to start a question. So here's what it's saying. It's moving in that direction. Okay, where this will be like 4 and 3. But it's actually going with 15. So that's not, the 15 shouldn't be there, it's just moving in that direction. So we don't use that yet. So what we can do here is we can find out what theta is. And basically tan theta equals 3 over 4. So put that into the calculator. And by the way, this is all because we need to start off with where is it at the start. We need to we need to know what V is at the start. We have to. If we don't know it, we're going to have to put something like A and B, because we've got to build our AVR. So let's keep looking at this anyway. So if I do that theta, it's shift tan 0.75. So theta is 36.87. Okay, so that's what I know. So now I know my actual velocity at the start. So if that's 36.87, it's moving with speed 15 in that direction. But I need obviously I and J. So this is going to be 15 sine 36.87. This is going to be 15 cos 36.87. I think they're giving pretty nice. I'm assuming. Let's have a look. Sine. Okay, so this one's 9. This one is. And by the way, make sure you've got your calculator and you're doing this with me as well. Feel free to pause anytime. That's 12. Okay, so we know that V equals 12.9. Now we can try to, normally, for most questions, we'd actually also be bothered about finding R. But if you see this question, it's actually got absolutely nothing to do with anything to do with R moving direct. It doesn't say where it's at or anything. You could do R equals, we just don't know what R is, but we're going to find we don't need it. But normally with questions you would, okay? So okay, we got our TV and we would have R. So we integrate, let's go to V. So can you see that's going to become xt plus 12 and yt plus 9. Okay, we're still doing the AVR. It's a 9 by the way. Now here, more information, okay? This is more important. So it goes at t equals 6. We know that V equals minus 12.6. Well, okay, let's shove in t equals 6 into here. Okay, t equals 6. So we're going to get 6x plus 12, 6y plus 9, and we know that has to equal minus 12.6. Well, this is nice and lovely now, okay? So you got 6x plus 12 equals minus 12. Rearrange that, 6x equals 24. No, it doesn't, minus 24. X equals minus 4. Great, so we've actually got one of the answers. We can do 6y plus 9 equals 6. What's y going to? Y is going to equal minus 0.5. And if I make like a dopey error, my apologies. But yeah, can you see? So the acceleration was minus 4 minus 0.5. But the main thing, my first aim is to build AVR, and I gotta go about TVR at 0. Except this one has nothing to do with that, so I don't need it. But does that make sense? I mean, if you weren't sure, and say you kind of just went on the way of always just doing R, you would have had to just basically do R equals, I don't know, AB or something, and you just would have done, you know, half x t squared plus 12t plus a half yt squared plus 9t plus b. It's an a. Yep. And you just would have never used this in the question. So don't worry. I mean, you can, if you want to just get into the habit of doing always AVR and you just want to kind of go blind, fair play. But did you notice it doesn't really give us any information, doesn't need it at any stage? That okay? So by the way, I want to build my AVR. To build my AVR, I need to know my V and R at t equals 0. That's where my aim is. And you're going to notice I keep doing this as we go through every question. And let's just kind of work through them. Question 2 is another one which I don't particularly like, but let's have a look. I just don't like the wording of this. I just don't think, I don't know. My gut says it won't come up like this anyway. So, okay, constant acceleration. So it starts by telling you the acceleration, okay? Good, we need that. We need to build an AVR. Okay, so first thing we need to know, t equals 0. What's it going to equal? So we know at, do we know anything about V initially? It goes at time t equals 0. P has speed u, basic u. So it's told us nothing. We have no idea. Okay, so I'm just going to call that x and y. Because speed isn't very useful to me. It's just saying it moves. You know, it doesn't know where it moves. It's like u here, u here. So, sorry, my bad, u here. So I'm just going to say whatever it is. Okay, here's your x and y. Okay, I'm just going to call it x and y. I don't care. Okay, so that's that. And can you see there's another one which doesn't involve r and stuff like that. Okay. So okay, so if I build that, I get 2t plus x, and I get minus 5t plus y, and nothing to do with r. So here's what now I know. Okay, now I can look at other things because I need an equation for this. I know at t equals 3, v equals minus 6 and 1. And you may already start kind of feeling out what happens. So if I put t equals 3 into here, okay, what do I get? I get 6 plus x minus 15 plus y equals minus 6, 1. This is giving me pretty straightforward stuff. So x will equal minus 12 and y will equal 16. Okay, so that's my initial velocity. My initial velocity is, you know, if I call it v naught, you know, minus 12, 16. But I need the speed, so I just need to do my, you know, square root of whatever. Do that. What's the answer going to be? I don't know, top of my head. 20. Okay, it's going to come to a lovely 20, which is always a good sign you've done it correctly. Okay, that's number 2. Again, do you see I started the same? I'm trying to get my A down. If I don't know my A, I've got to put X and Y. I need to put something down for V and R, but this doesn't involve R. So V I didn't know any information about, so I just called it X and Y. Because I need something to build my AVR. So question 3 now. Okay, and you know, make sure you pause along with me and stuff and actually try to do this. Particle P moves in a straight line with constant velocity. Initially the point P is at point A, we position that, blah 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 blah. Okay, let's have a look. So it doesn't look like it's giving me anything to do with A, so A is going to be my X and Y. Initially it's at position, so let's kind of do this. Okay, so at T equals 0, it's moving with constant velocity. Oh wait, constant velocity moves in a straight line with constant velocity. So what that's telling me is actually it's my velocity is x and y. Is that correct? Have I got this? Wait, am I missing something here? These are pretty, yeah, and these aren't the loveliest questions in the world. Okay, constant velocity, that's telling me my acceleration is 0, 0, because it's constant, okay, it's not increasing, so it's x and y. We don't know, so like initial velocity, well, it's just going to be the same every time, isn't it? It's x and y. So that's what I know. Actually, this is how I should have started. As soon as it told me it's constant velocity, it tells me acceleration is 0. but I don't know what that is. R, let's kind of get R here as well. Initially, it's at the point with position 4 minus 3. There you go. Let's build my AVR. Okay. So that's going to be X and Y. Can't do much with that. Here, that's going to be xt plus 4 yt minus 3. Okay, let's see what we know. Okay, at t equals 3, here's what we know. T equals 3, velocity is still going to be the same because there's no t involved here. I know that R, so you can sort of say, it doesn't really matter. I mean, I know it's X and Y, but whatever. Okay, R is going to be minus 5, 9. So again, when it says find the velocity at P, it's really saying find X and Y. This is where it's going to be, okay? So I can put T equals 3 into here. So I put T equals 3 into there. What do I get? I get 3x plus 4, 3y minus 3, and I know that has to give me minus 5 and 9. I'm just going to do this pretty quickly. Hopefully this is not the kind of stage where you need me to kind of explain it. It's going to be what? Minus 3, and that's going to be 4. Okay, so that I've just found my velocity. I found my initial velocity, so that's all done. Okay, so I know, and by the way, as soon as you find it, so for this one, this answer is minus 3 and 4. I want to update this, by the way. I actually know what my thing is. If there's ever any x and y's involved in your initial equations, make sure you update them. Because, well, let's have a look anyway. Just rob this out to make a bit of space. Because when t is at when t equals 5, p is at point C. Okay, so t equals 5. I care about what r is here. I mean, it's going to be pretty straightforward. I just put 5 into there. Okay. So R5 will equal minus 15 plus 4, 20 minus 3, minus 11, 17. So, you know, let's kind of just have a look at what kind of it said. So initially started at, I know this isn't correct because I'm in the x and y is incorrect, but like, you know, it started off like, imagine that's minus 3, this one ends up at oh, this is a horrible sketch. You know what? I'm not going to do this shoddy. Even though I'm a big believer in your sketches, don't worry about being too accurate. So it started at 4. Oh, hit my bad. 4 minus 3. So it's like somewhere here. 4 minus 3, and then at t equals 5, it is at minus 11. So where's that down here? 17. Yeah. Basically, can you see this is, you just need to do Pythag again. So this distance was 20, this distance was 15. Just do Pythagoras, you know. You got the distance. 25. So I was going to check the answers to make sure I'm definitely correct. I mean, we can do it. But when I get 25, I'm not going to be wrong. That's just too lovely. The thing, so it's minus 3, 4. There you see. Can you see it? 25. Okay, let's go to the next one. Hopefully that makes sense. That was a good question to look at, actually. Just like kind of like what have I done there? Just to kind of like pay attention to the wording in terms of like constant velocity. Constant velocity. Yeah, if it's, think about the speed distance diagrams. If it's moving with constant speed, it's like a flat line. It's got 0 acceleration. Okay, you notice as we kind of go through this, you feel better and better. If you don't already kind of feel like, yeah, this is clicking quite nice. Okay, here we go. Straight up. It's like I just want to go straight into AVR. Okay, constant velocity. Okay. So I know A is 0, 0. Let's have a look. So I know that t equals 0. Because it's moving with a constant velocity, so that velocity is not going to change over time. So that is just going to be 3, 2. At respect to a fixed point origin, it passes. Okay, at t equals 0, it says R is at 211. Excellent. I can build my AVR. 3t plus 2, 2t plus 11. Okay. Find the angle in degrees that the velocity vector of p makes with the vector I. Okay, so let's have a look. So it's going at 3 and 2. 3 and 2, remember I is like here. So basically it just wants that angle. Tan theta equals 2 over 3. Untan the damn thing, and let's see what we get. 33.69. So there you go. First one is 33.69. Here's a nice 4 marker. Calculate the distance from O when t equals 0. So okay, so obviously here's what it's saying. It goes, it's going from the origin. It's like, where is it at t equals 0, and calculate the distance. So if we kind of find the spot, we're just going to do like, you know, Pythag on it. Basically shoving t equals 0 into there. And actually, you know, can you see, like, as we're doing AVR, that 4 marks, you're like, oh, really, they're giving me 4 marks for that? Yeah, they're giving you 4 marks for that. So R2 is going to equal what? 6, 8, 15, and there you go, just square root here. I mean, I could do a diagram, probably should do a diagram, but I don't think this is, I don't think it's likely to catch you out. I mean, anything can catch you out, so if it does, don't worry about it. But there you go, 17. Lovely, lovely 6 marks. Okay, question 5. And I always say this when I'm kind of making videos. Always pause the question, do it, and then you can obviously, well, you have a mark scheme, so you can check against it, and then you can just use this as, was I right, was I not? Okay, moves with constant velocity again. Oh, God. I mean, it's fine, you know, it's absolutely fine, but let's have a look. Okay, so I'm immediately, before I even go read the question fully, I mean, I do recommend give the question a full read through, but I know how AVR works. It's just like, I just need what's happening at t equals 0. So I know it moves with constant velocity. Does it tell me anything about the constant velocity? Not really. So I'm just going to have to call it x and y. And it's constant, that's all I know. Let's have a look. At a boat B moves with constant velocity. At noon, it looks like we're starting from noon, yeah? Is at the point position vector that, okay? So we're starting to that, okay? So R equals 2 minus 5. So let's build our AVR first. X, Y, R equals xt plus 2, yt minus 5. Okay, and now we can get into the question. So does it say anything about like t? So t is going to be in hours, by the way. Okay, so let's say it says find the velocity of v. So I mean, this is like a silly question because it's like, it looks like t is in hours. You'd think they'd kind of say earlier on, but t is in hours. So if it starts at noon, which is at 12, and then we know at 2:30, yeah, 14:30. Can you see that's good? That's 2.5 hours later. So we're dealing with t equals 2.5. So there's like a cheeky way of them trying to give you t, but not give it you too nicely. We have no idea what the velocity is. So we have no clue what velocity is at that time. What we do, it's actually constant. It's x and y there, but yeah, that's not the important bit of this question. But we do know it's -8 and 10. Okay, at t equals that. And that's going to help it. So velocity of b, it's just saying can find x and y. We're going to shove t equals 2.5 into there. So let's kind of get our 2.5. So you get 2.5x plus 2.5y minus 5 is going to give us -8 and 10. So just get the calculator. Let's kind of find out. So we know that x and y equals so -10 over 4. That should be minus. Let me actually do that. Let me not be stupid about this. -10 divided by 2.5. Yeah. -4. If I do that one, 15 divided by 2.5, 6. Yeah, good. Okay. So I've got this one done. It's -4, 6. Okay, which means I should update this. I should definitely update this. Because remember, I know that this one now is minus 4, 6. Bearing of the velocity vector. Okay, so I know that it's going minus 4, so it's going that way, 6. Okay, so I need to find that thing, so it's going 4 that way. No, what am I doing? Okay, let me drop this out. It's a tip and a half. Okay, velocity vector minus 4, 6, so it's going that way. So it's 4 and 6. And if you want to think, because it says bearing, by the way, imagine if I do this on an x and y coordinate. Can you see that's 270 over there? So I'm just going, I need to find this little theta thing here so I can just add it to 260. Pretty nice. Can you see that's going to be tan theta equals 6 over 4. So if you just untan that, you'll get theta equals 56.3. So as a bearing, you just do 270 plus that equals 300 and dyslexic there, 326.3. Okay, 326.3. Let me just double check I haven't made some silly error on that. Which is it? Number 5, yeah? Which one am I looking at? Am I looking at my number 4? No. Yeah, 326. There you go. That's correct. Okay, let's have a look at this one. An expression in terms of t for the position vector after t hours afternoon. Here you go. There's your number. There's your number C done. Okay, so what you'll notice a lot of times with AVR vectors is you might be doing a 2 marker, which you're like, oh my god, I've done, this is taking me quite a lot. You're like, this much work for 2 marks, and then later in the question there's a part which is like 5 or 6 questions, and the work has already been done, and you just put it down. In some ways, revising for mechanics is the hardest, because when you use smarter methods like AVR and stuff, and the working outs in Suva and all of that kind of stuff, it can be hard to kind of follow, but it can also be hard to follow because normally if you're in a pure exam and it's a 1 marker and you've been at it for about 5 minutes, there's a better way of doing it, assuming your stuff you're doing is always right. But with mechanics, no, it can be tough to tell. Okay, nice 11 marker. Let's see how this one goes. Okay, all right, let's have a look at this. So it has an initial velocity of that, so that's telling me something about my t equals 0. It's telling me the initial velocity is 1 minus 5. It's saying acceleration uniformly, so it's just told me what my acceleration is. That's going to be useful. Good. Yeah. Given that the magnitude of the acceleration, given that the magnitude of the acceleration is that, isn't it? Oh no, I've got to be careful. Okay. They've done this little cheeky question again. They said it's accelerating in this direction. Not actually that. It's not saying that's the acceleration. It just goes, it's moving in this direction without be 2 and 1. But really what's going to happen is to find out my actual acceleration. That's going to be 3 root 5, and I need to bring the angle in so I can find I and J. Okay, so tan half. Let's find what this angle is. To do that right? Yeah. 26.57. So this is 26.57. And now I can work this out. Okay, so this is 2.236. Okay. And this is 6. Is that correct? Well, let me double check this one. Oh, that should have been 3. Don't know what I did wrong there. Got 3. Well, that's promising. And let me just do 3 squared plus 6. Oh, fuck's sake. Bear with me, bear with me. Feel free to skip ahead whilst I do this. Yeah, okay, yeah, got it, okay. So, alright, great. So I know my acceleration is actually 3.6. It's a bit of a pain in the ass to kind of like get to the point of where I actually get this correct. But, you know, needed. Show that, let's have a look at this. Okay, show that, so like, if I now I can do my velocity. So now that's going to be 3t plus 1 and 6t minus 5. Well, that is my, is that me done? Have I done this correctly? Have I made some silly error? It looks like that's what it is. What's that kind of thing? 6t plus 1, I. What have I done? Oh yeah, of course. I've kind of got these the wrong way around, haven't I? Yeah, that should have been 6.3. There you go. And that's you know, like one of the most common things I say. I hope you understand that I still to this day make errors. Well, there you go. There's a good proof of it. So can you see? And look at that. 6 marks. It's actually not bad, right? Okay, using your answer. By the way, did you notice this one has nothing to do with R, so I can skip R. But if I, yeah, anyway, okay, let's go on. Using your answer to part A, otherwise, find the value for t for which the speed of the particle is at its minimum. So one sec, let's have a think about this. Using your answer to part A, or otherwise, find the value of t for which the speed of the particle is at its minimum. That's actually quite an interesting question. That's making me think. So, okay, we always know that this is the velocity, okay? Now, I know this isn't strictly correct, but, you know, I mean, we don't know what direction it's going, but this is always going to be 6t plus 1, 3t minus 5. So if I want to find the speed, it's always going to be 6t plus 1 squared plus 3t minus 5 squared. Does that make sense? Yeah? So I know that's what my speed is always going to equal. And I'm trying to find the t at which it's minimum. Still thinking how this is going to work. Let's just go into, let's see what happens. So this one will give me 36t squared plus 12t plus 1 plus I'll get 9t squared. Let me make sure I don't make some stupid error on this one. Minus 30t plus 25, all square rooted. I should probably give myself a little bit of space. Okay, so if I add that together, I get 45 t squared plus, minus 18t plus 26 all squared. I mean, I've got a way which I can kind of, because imagine that's a speed, yeah? So I could sort of differentiate this and find out where it's a minimum, if you know what I mean. Wonder if there is a better way. Okay, let's go about it the way which I'm thinking. Does that make sense? Okay, so right now I sort of have like an equation, say that's like t, and if I call speed y, yeah? So if I call speed y, can you see I've got like y equals 45 t squared minus 8t plus 26 all to the half. If I do dy by dx now, so you know it's got kind of like a curve. I'm just trying to find out where is it the minimum, because obviously, you know, where is it the minimum? This can't be it. This can't be right. This cannot be right. Could it be right? Give me a second. Give me a second. Let me pause this video. Let me actually think, because otherwise I'll waste God knows how much time. Okay, so I just had a look at the answers, and yeah, actually this would have worked to differentiate. Here's one thing we could have done. So if you differentiate this and find t, that's going to be correct, and that's one way of doing it. But there is sort of like a little smarter way of doing it. So it's like, you know how we know speed equals that? Well, also we might just square both sides, because speed squared is just, you know, I mean, speed is always positive anyway. So we could square it and just get 45t squared minus 18t plus 26. And sort of treat that, and almost kind of treat that as like a W, and just say if we can find the lowest point for where t works for that, then that will work as well. By the way, the minimum value, so we could differentiate it, and that'll be pretty straightforward. Or we could actually complete this square as well. You know how when you get something like y equals x plus 5 squared plus 14, you know, the minimum happens when x equals 5, but it's 14 at its minimum. So we could do that, differentiate. I'm just going to do the differential way as well. So that'll be 90t minus 18. We want it when it equals 0. So when you rearrange it, what do you get? You get t equals 18 over 90, which is 1 over 5. So there you go, that's the answer. So unusual question, for sure it's an unusual question. But that's why we do these questions. We just have a look at them and give it a go. I was actually also wondering, no, I can't say that. No, my bad. That's the only way which there is, as far as I'm concerned. Top 5 marker for sure. Hopefully that made sense. And all you do, like, from when you kind of run across these questions, you are going to run into stuff which is going to, like, you know, how do you do that? All your aim is, do I fully understand how that makes sense? Okay, let's have a look at this stuff. Okay, so let's have a look at this. So we have a boat at midday, which looks like it's going to be where it kind of starts off. It goes at midday. A boat is 5 kilometers east of a fixed origin. That's actually telling me where it is. That's telling me the initial position vector. I'm moving with there's that word again, constant velocity. I know my acceleration is 0, 0. Okay, and it's told me the velocity as well. So let's kind of put down what we know. So at t equals 0, we know that v is minus 6, 5, which will actually make our actual velocity as well. You can call it v naught as well. So what am I doing? Yeah, that's not important. T naught, v naught. And here's the thing, at midday, oh, there's 2 boats involved. Okay, this is going to get more interesting, yeah. Okay, so this is the AVR, by the way, for our first boat. Okay, so the R, it's 5 kilometers east of origin O. So imagine that's origin O. So east, you know, never eat shredded wheat. East is that way, and we're 5 kilometers that way. So can you see our initial position vector is 5, 0. So let's kind of just quickly build our AVR. R equals minus 6t plus 5, and this is just 5t. Okay, so this is boat A. Because by the way, if there's more than one boat, you got to do two. You got to do 2 AVRs. Every particle has its own AVR. Just like when you think of F equals ma, each particle in there gets its own F equals ma. So if there's anything like that, you know, it's the same thing. Okay, so now let's have a look at this one. At the same time, another boat is 10 kilometers at the same time. So this is going to be the initial thing as well, yeah? So this t equals 0. Its velocity, yes. By the way, uniform velocity, that's another way of saying constant. Okay, that's the same thing. I don't know, so they decide to show you 2 ways of writing it. So we know it's moving at minus 4, 1. And we know it's R, this time it's 10 kilometers north of O, so it's like here. So this O is 0, 10. So we build the AVR, 0, 0, I should have written that earlier, moving with uniform velocity. V equals minus 4, 1, and R equals minus 4t and t plus 10. Okay. Whoa, all of that before we even started going for the question. So it goes, show that t hours after midday, the position vector of A is 5 minus 6t. There you go, 5 minus 6t, which is got minus 5t. So there you go, that's done. Ding. Show at the same time the position vector, oh, there you go. So Wait, have I done something stupid here? So this one's not matching up for me again, so it looks like I made a dumb mistake. So at the same time, position vector of B is relative to A. Oh wait, that might be okay. I might still not be wrong on that one. No, I think I made an error. But I'm thinking of this relative to A. Let me read this again. At the same time, when it's starting, it's at 10 kilometers north, so I agree with that one. And is moving with -4,1. Yeah. That's a pain in the ass, that one is. I was a thinker. No, I got it. This one's cheeky. Okay, what we've done is correct. Position vector of B relative to A. Relative to A. So basically, if A's here, then this becomes like a 0, 0. Okay? And as it's moving, it's almost like that keeps becoming the 0, 0, which is strange. So the way we do that is by doing this take away that. Does that make sense? We do this take away that, which will give us what we want. And that's a cheeky relative to A, okay? So for part B, can you see we'd do -4t, t plus 10, minus 6t plus 5, 5t equals, well yeah, that's going to give you 2t, because -4t minus that gives plus, -5, that's going to be t minus thing, so -4t plus 10. Ugh, cheeky as hell question. Okay, using your answer B or otherwise, show that the boats would collide if they continued at the same velocities, and find the time at which the collision would occur. So we've got two ways of doing this. I actually hate this part. It's so not necessary, and in most questions this will not come. Okay, but if you kind of, yeah, I hate that. Absolutely hate that. One way we can do this, so it's kind of saying if we, with this relative thing, we can kind of find out, oh god, I hate this. They collide if they've got the same, okay, I'm going to show you the way I prefer first. So think about this, okay? So boat A, you know, it starts out here and it starts moving however it does, -6, 5, so it starts, no, it doesn't, it goes -6, 5, okay, so it starts moving in this direction, somewhere here. At the same time, you know, boat B starts here and starts moving in direction here. So obviously, can you see they would collide here? You get like a Titanic kind of thing, both of them go down. Well, one way which you can actually kind of find that they collide is by trying to find out when this equals that, when their position vectors are the same. Okay, so I'm going about the otherwise way. So you can kind of say, you'd basically make that equal. So you say -4t plus 10. It's like collide when both of them are equal. So let's have a little think about that one. So if I bring that over, so can you see the top line would give me 2t equals 5, so t equals 2.5, and let's do the bottom line. So this would be -4t, no, I might as well move that t to the other side. You get 4t equals 10, which also gives you t equals 2.5. So what I've kind of found out is that the point of 2.5 and after 2.5 hours, they have the same horizontal position and the same vertical position, hence they've collided. So that's how you show it, okay? That's how you show it using the otherwise, which is what you're going to use more often than that kind of relative thing. The other way you could do the relative thing is because you sort of, that's sort of hard to explain. It's basically when these two are going to equal 0, 0. Okay, so it's like A is always made 0, and it tells you boat B, in terms of when this thing is 0, 0, has this position. So it's like a moving 0, 0. Well, if it's going to collide, you want B to be at 0, 0 as well. So you just sort of make that equal to 0, 0. And you can kind of see over here, you see at the top you get 2.5 and at the bottom you get 2.5. So you've shown that the I and J are the same. There's a certain time which their I and J's are exactly the same. Therefore they have collided. Perfectly lovely question. They could just literally ask that without having that part B. And to be honest, that's more often how you're going to be asked. So just understand what I said with part B in case they try to throw like a 2 marker. But I promise you, you will not need it. You can just kind of use your brains, and it's actually much easier in my opinion. Okay, let's look at number 8. Big block of text. Big block of text. 13 marks. Okay, how many boats is there? There's 2 boats on this one as well, so we're going to need 2 AVRs. So let's kind of do AVR. Boat A. And hopefully this doesn't have that stupid relative rubbish. Okay, so let's have a look. Okay, 6 a.m. So yeah, 6 a.m. is going to be our t equals 0 as well. Okay, at 6 a.m. boat A has position vector that, so we've already got the R. Its R is 12 minus 11 relative to fixed origin, and moves with constant velocity. So we know it's A equals 0 as well. 0, 0. And we know it moves with V equals 9 minus 6. Build the AVR. 9 minus 6. R equals 90 plus 12. This is minus 6. T minus 11. Yeah, another boat moves with this one, so like at t equals 0. That one's at a constant velocity as well, so A equals 0, 0. V is minus 12, 15, and its R is, what is it, 40 minus 39. So again, a very nice straightforward AVR build. These questions actually cause a lot of headache. People don't like it when they're kind of colliding and stuff. But as long as you know, hopefully this makes sense. It's actually much nicer than it can seem. Okay, so find expression of the position vectors of A and B. Well, it's this one and it's this one. Okay, so that's that one done. It's actually very lovely. Show that if both boats maintain their course and speed, they will collide and find the position vector at which this occurs. So okay, so they will collide when these two are the same. Okay, so when it's I and J are exactly the same. So if I kind of say collide when 90 plus 12 minus 60 minus 11. And actually, here's another way of looking at it, which actually might be kind of like nicer. So if they collide, yeah, if they collide, horizontal position must be same. Does that make sense? It's like they must be on the same x axis or y axis. So you can kind of say, so when, let's kind of find out when that happens. That'll be when 9t plus 12 equals minus 12t plus 40. Okay, so if we rearrange that, I get 21t equals 28. So what's that going to equal? It's going to be 4 over 3, isn't it? Yeah, 4 over 3. Okay. So now what I do is to say, okay, well, we just kind of check what. God, I'm overcomplicating this. So you could either do at t equals 4 over 3, what does this equal, what does that equal? Or you can kind of just say if collide must be same. Does that make sense? Not written in the best way, but hopefully that makes sense. 15t minus 39. So let's kind of do that. So if I bring that over, I'm going to get 21t here. If I take that over, I get 28. I get the exact same t, okay? So can you see it? I know at the same time, they've got the same I positions and the same j positions. Therefore, they must be in the same position. Therefore, they have collided. It's not like a boat can kind of stand on top of another boat. They have collided, okay? And then the final thing, so it's like, what does it say if the boat's made? Find the time. So t equals 4 over 3. And the position vector, which that happens, well, because we know they're the same, just put t equals 4 over 3 into any of them. They'll give you the same. So let's kind of just do that. 9, 4 over 3 plus 12. What's that going to equal? So that'll be 3, 12, 24 would be the top one. Minus 6, 4 over 3, minus 11, that's a bit more of a headache, minus 2, minus 8, minus 11, minus 19, assuming I haven't made an error there, okay? So the position vector is 24 minus 19. If I've made an error, it's a silly one. Find the distance between the two ships find the distance between the two ships at the time when they would have collided. What does that mean? Literally, what does that mean? I think it's 0 if they've collided. Find the distance between the two ships at the time. Oh wait, no, my bad, okay. I didn't read that bit, did I? Always read the question. At 7 AM, oh, this is actually quite difficult thing, okay. Okay, at the time we know it would have collided at t equals 4 over 3, okay? So okay, so boat A at 7 AM, it realizes that the collision is going to happen, so obviously it's smart. It's like, let's change course, otherwise we're all going to die. And it now has velocity minus 1821. So now what we're going to do, because something has changed here, we're going to have to build a new AVR. This is similar to like when we're doing F equals MA and an extra force is added or taken away, where we've got to do the whole F equals MA again. Now, let's think about this, okay? So it's acceleration. So, by the way, this happens 1 hour later. Okay, so all of this whole question begins at 6 AM and it goes at 7 AM, the boat A decides to change it. So let's kind of make a new AVR for boat A. Now, remember, if we're going to need t equals 0, which happens now at 7 AM. So we know it's new velocity, and we know it's still at the its acceleration is still 0, 0, because I'm guessing it said it changes its it changes its velocity, but it's still kind of like, you know, constant. Okay, so we now know that it's minus 1821. Now, here's the mistake a lot of people would make, even if they knew how to get this far. They'll be like, oh, but the position vector is still that. No. Okay? The problem with this is here was the boat, okay? So it was at, what was it, like 12 minus 1 here, and it was moving what? It's moving downwards, wasn't it? Was it moving downwards? Yeah, it was sort of moving that way, okay? This is at 6 AM. It's moved downwards, so at 6 AM it's at 12 minus 18, but after an hour it's over here, and this is where we're building our AVR from, this point. So we need to find this point as our start at our t equals 0 for our AVR. Does that make sense? Yeah. And okay, so the way we do that is we put t equals 1 in there to just find out where it was at 7 AM. Does that make sense? So r is going to equal, well, 9 plus 12, 21, and minus 6, that's so minus 17. So it's starting at minus 17. 21 minus 17. So we say v equals minus 18, 21, and r equals 21 minus 17. No, what am I doing? It's completely wrong. Minus 8t plus 21. Is that right? Yeah, assuming I haven't made like a dumb error. Okay, so that's the new AVR. Okay, now it goes. What would the distance between the ships have been at the time when they would have collided? So we know that boat B is at this position. Okay, So we just need to find where bow A is at that position. Now we've got to be careful here, okay? Because they collided at t equals 4/3 when they both set off at the same time. Okay, this is like 1.33 hours. Does that make sense? Yeah. Well, at 7 a.m. it changed. Okay, so 1 hour of that's gone. So using our new AVR, we actually only put t equals 1/3 into there. Because another way to think of it is they would have collided. So you know how it said 4/3 hours, yeah? So that's 1 1/3 hour. That's like saying 1 hour and 20 minutes. Okay, so if they went off at 6 a.m., they would have collided at 7:20 a.m. Does that make sense? So it's all good. I mean, so this is this one never bothered to change. So this is where it's at 7:20 a.m. But for this one, okay, bear with me. But for this one, because this one sets up at 7 a.m., so you just need to put in 1/3 so you can get those extra 20 minutes. Hopefully that makes sense. Okay, so minus 18/3, sorry, plus 21, so that'll be minus 6 plus that's going to equal 15. So if I put it into there, I'm going to get 21/3, which is like 7 minus 17 equals minus 10. And again, if I made an error, my bad on that one. So okay, this is at, so we know that's at 15 minus 10, that's at 24, so that's at 24 minus 19, and that's at like 15 minus 10, so 15 minus 10. So we just need to find that distance, which can be done. You can sort of take it away to see what the distance between them, but hopefully that makes sense. 9, 9. Is that right? Yeah. So you just do, to find the distance, just do 9 squared plus 9 squared. So what's that going to be? 81 at 81. I know what it is, but let's not take risks, right? Yeah. 12.73. There's a good chance I might have made like a dumb error across that somewhere, but the working should have been correct. Yeah, I have made a dopey error somewhere. It looks like 8 kilometers. What have I done? They were collided at 7:20. Yeah, you can see a lot of this is correct. I don't know, man. I've made a dumb error. Let me kind of check my original R's were correct. 90 plus 12, yeah, that was defo correct. Actually, I can't imagine they're wrong. It wasn't bloody hard at all. Minus 6, minus 11, that was correct. 40 minus 12 t, was it 40 minus 12? Yeah, 15 t. Yeah, so all of these were correct. I don't know. Like an error's made. Hopefully that kind of makes sense. Anyway, position vector thing. 21 minus 17 was correct by me. That was correct. 24:19. This was where it was at. Yeah, this is correct. What have I done now? I don't know. Like I made some error somewhere, but hopefully that makes sense. That's the biggest thing. Whoa. Down to the final question. Here you go. Okay, at 10 a.m. Two plane note again. Okay, so plane A, plane B, 14 marks. Okay, so 10 a.m. Okay, so let's have a look at this. Moves with constant velocity. That one moves with constant velocity. So we know for both of them, A equals 0, 0. A equals 0, 0. Plane A, what do we know? At t equals 0, we know its velocity. It's minus 4, 6. We know it's at the position vector of 2, minus 5. Let's build the velocity. Let's build it. There you go. That one's done. What's this one? T equals 0. V equals 1, 8. R equals minus 3, minus 9. So velocity is 1, 8. And V is T minus 3, 8T minus 9. Okay, whew. Find the relative displacement of plane A from plane B. Okay, so what we're going to do is we're kind of setting this set as 0, 0. So if you want to find the relative displacement of A from this, we're going to do this one take away that one. Does that make sense? So if we do that, relative is it's going to be that take away that. So it's going to be minus 4t plus 2 take away t minus 3. So I'm going to get minus t, that's going to become plus, no, not brackets, minus 5t plus 5 should be the first one. The second one, 6t minus 8t, so I'm going to get minus 2t, minus 5 minus minus 4, so it's going to be plus 4. Okay, so hopefully the relative one, relative r, oh, I dropped it out, didn't I? Yeah. Minus 5t plus 5 minus 2t plus 4. I'll double check that's right, so I'm just not wasting time. 5 minus 5t, yep. 4 minus 2t, excellent. Okay, so that's the relative. So let's have a look at that, that one's done. Find the time when A is due west of B. Okay. Alright, so let's kind of, let's actually kind of think about what that means, okay? So imagine B is here, okay? So what this is saying, like, if I just kind of show you as well, I think this would be nice for you to kind of see as well, yeah? So you know, A starts at, where does it start? 2 minus 5, okay? So A starts here, and it starts moving in what, minus 4. So it starts moving in this direction. That's the path it takes. Where B starts at, one second, I'm just using colours. Starts at minus 3, minus 9. Wait, if A doesn't start there, does it? What am I doing? 2. Yeah, it does actually. So this one starts at minus 3, minus 9. So it starts somewhere like around here. B starts. And it starts to go that way. Okay? Now, this has got nothing to do with collision. It's got nothing to do with collision. So it goes, you know, there's a certain point where, like, when B is here, you know, can you see when B is, it's like, if I move it that way, A is going to be north, southwest. A will be like here. Does that make sense? A is there. And, you know, if you can kind of see where that is, can you see somewhere down here, you know, there'll be a point where B is there, A is there, and it's literally A is west of B. So now have a think for a second. How would that, what would have to happen for that to happen? What would it have to be? Well, okay, if you can kind of see it, their I isn't, as in like their I coordinates are different, but to be west, their J's have to be the same. So that means, I mean, if you weren't doing that relative displacement rubbish, it just means that this has to be the same as that. Does that make sense? Okay. Or in another way, if you're thinking about the relative ones, the bottom one has to be equal because you're saying there's no difference in their J's. So it really doesn't matter which one you kind of do. I prefer the first one, but seeing as this relative stuff keeps coming up, I guess you can use the relative one. Probably involves less work. So it's like minus 2t plus 4 equals 0. Well, it's going to be 2 equals 2. Does that make sense? Another way you could go about it is make that equal to that. 6t minus 5 equals 8t minus 9. So over, yeah, you're going to get the same thing. You get 2t equals 4, so t equals 2. So the answer is 2 equals 2. Oh, but here's the thing. You know what I'm saying? So I'm doing some very stupid things, by the way, guys. You know where it's like, where it says find the time, where it says they set off at 10 a.m. Okay, and now we found it happens at t equals 2. So the answer I should be given is 12 p.m. Does that make sense? Yeah, and actually should have probably done that on the previous questions as well. It's just a context thing. Now here's an interesting one. It goes, find the time after 10 a.m. when the planes are exactly 37 kilometers apart. And again, you know what? You can do this in two ways as well. It's just to understand that there's always the difference between these two things. So basically, imagine A is here, imagine B is here. To find its distance, which is, you're being told is 37, you sort of you can do like a Pythag on that. Okay, so does that make sense? So you know that the distance between these two is actually minus 5t plus 5. That's actually why they're asking you to find that in the first one, because it is actually useful to have that. Otherwise you just do this, take away that, or vice versa, you know. And the difference between this one, if you do that, take away that, is actually going to be minus 2t plus 4. So they're saying find t, you know, find the time after which it's exactly 37 kilometers apart. You're going to use Pythagoras. Okay, so you're basically going for when minus 5 plus 5 squared plus minus 2t plus 4 squared equals 37 squared. Okay, and then we're going to get a nice quadratic at the end of this. 25t minus 50t, and again, don't do it this quick, you know, but I'll be honest, it's boring, so I'm just getting on with it. T squared, look at that, almost a mistake crept in there. Minus 16t plus 16 equals what's 37 squared? 1369. Now it's pretty straightforward, you know. It's just a quadratic from here. Minus 66t plus 41 equals 1369. Obviously take that away. Put it into the calculator. Okay, I get t equals 8 and minus 5.724, and you want to show both of them. They're very picky, yeah. Even though it's obviously got to be the positive time, it's not like you can go back in time, but you want to show that. Maybe put like a little cross, do t equals 8, okay, which means it's 8 hours after 10 a.m. So 8 hours after 10 a.m. is 6 p.m. And especially when you get a lovely number like that, you know you're right. But it could be ugly. It doesn't matter if it's ugly, okay? The answer is 6 p.m. Whew. Okay, yeah, hopefully that makes sense and all of that. But this is, I mean, just like a quick point on that, yeah? This one, make sure you fully understand that one, the time when it's due west, because they don't always collide. It sometimes say when one is north. Let me give you like a few examples of some of the stuff they'll actually do. So, you know, it could, so imagine you've got an R R, if that's R of A, so imagine that's 6t and that's 4t plus 8 or something. I'm just making this stuff up, okay? So like something's moving in this direction. 14 minus 2t and 16. Okay? So if they collide, you know, basically these two are the same and these two are the same. Okay, that's when you collide. Now imagine if something says when A is north of B. How would you do that? Well, let's kind of think of just like a diagram here, okay? So imagine B is there because we're doing north of B, so you treat that like B. You want to go when A, well actually no, that's a crap diagram. Okay, so B could be anywhere. Imagine B is here. We're bothered when A is there. So what is exactly the same? Can you see it's when the eyes are the same? So to figure out the time then, you would actually kind of make these equal. Does that make sense? And then you can find the t and all of that. Let's kind of go for something else. So when it goes, when B is east of A. So let's kind of do that. Here's A. And again, this is very similar to what I do in, you know, when we're kind of like picturing pure questions. And I'm like, just make a crappy sketch for yourself. It doesn't actually have to be accurate. I don't know if A is in the positive quadrant. It could be down here, could be down there. I don't care. This is just for me to get my head clear, okay? So when B is east of that. East is that way. So when B is here. So what's the same? Their J's are the same, okay? So this would mean I would make these two equal, okay? So 6t plus 5 equals 4t plus 8. And whatever time that is, that's when I know that. Now, there's so hopefully that makes sense. This is the good one. This is the good one. Okay. It could say, so now this will usually be one question, all right? So say that, okay? It goes, when A is north, let's go start with northeast of the origin. So now let's kind of have a think about that, okay? Obviously that's O, yeah? And obviously A travels somewhere. But we're interested, northeast, by the way, is that line, which is essentially like y equals x, if you know what I mean. And we're looking for the time when this thing is here. So the i's aren't the same, the j's aren't the same. So this can be very difficult. What is it going to be? But here's the thing. To be northeast, it could sort of only be at 1, 1. It could be at 2, 2. Do you get my point? It could be at 10, 10. That's how you get northeast of something. So what you kind of say is you want it when basically the i's and j's of the position vectors are the same. That's how you get northeast. And what you do is then you just treat that like a simultaneous equation, except it's simpler than that. So you're basically saying x, we're looking for it when it's x equals that and 4t plus 8. So you just literally substitute this into here and you get 6t equals 4t plus 8. Basically you're making it when these two are equal. Does that make sense? Yeah, that's what you're doing. Yeah. And let's just kind of have a look at a few more examples of like if I change it kind of there as well. Okay. Imagine if I said southeast of O. So again here, you know, here's O. Okay, southeast is down here. So if I kind of just think of like a example, so that could be like 3 and that'll be like -3. So I kind of think of that. So this could be anything, but I would want this to be the negative of that. Does that make sense? So what you can kind of do is you can kind of maybe say something like 6x equals 6t and you look for -x equals 4t plus 8, which if you kind of then just change that to x equals -4t minus 8. Does that make sense? And now you can make those two equal. So you have like 6t equals -4t minus 8. And you can solve for t and all of that, okay? So that's how that works. I mean, the northeast, northwest, southwest, southeast, whatever, yeah? It all works from that kind of logic. So, yeah, there you go. There you go, okay? So hopefully a little bit of extra. Something which may catch you out, but hopefully now it shouldn't, right? Yeah, how long has this video been? Oh, bloody hell. Okay, yeah, but hopefully it's helped.